All right, we got another production run going through the shop, and this time around it's a slightly different product. I'm not going to show you every little step along the way, but I'll show you the stuff that's different. Right now, we need to get on to populating these circuit boards. So this time around, we're making what I call the Wave Runner. It's basically an industrial MP3 or WAV file player, and it has features on it that lend itself well to industrial or amusement applications. First thing we have to do is apply the solder paste just like last time. And I had some questions about the solder paste, whether this was leaded or lead-free, and this is a lead-free solder, and I've been using lead-free solder for over 10 years now on all of our products. And this particular solder made by Loctite, it doesn't have any requirements to be refrigerated. Long time ago, when solder pastes first came out, they had to be refrigerated, and so before you used them, you had to bring them up to temperature, and then typically whatever you got out and you didn't use was disposed of. This is much nicer. It doesn't have any refrigeration requirements, and any we don't use, I just put it back into the container. And then we give it a squeegee across here, and that should be good to go. So I just had an airline pop on the pick and place machine, and with the age of this machine, that's not too surprising. This is not the first airline that has popped. So this is just a little clamp that mounts here, and that clamps the circuit board against the front rail to keep it always in the same alignment. And we blew the orange line here. It's just a push to connect fitting, but the hose broke off inside the fitting, so we'll have to get that out of there. We'll take this over to the bench and see what we can do about it. Just taking this out to get it out of the way. Taking it off would help or not. Hey, we got it. I think we can put that back in and plumb it up. Give this hose a nice clean cut. Looks pretty good. So this goes to the front. This goes to the rear. There's a nut in this rail back here to make these adjustable, so now I gotta find where the T-nut is. You gotta make sure it's not binding. I can put this into manual mode and check. I think we're good. Fire it up and get back into the program. This particular circuit board has several different options that you can load, whether it's all external triggers or if you're going to use what we call our Pro Audio option. This particular order is getting that option, and I have that set up as a separate run through the machine rather than using what is really a limited amount of memory space and to duplicate what would be the entire program twice just to add a few extra components. All right, now we're going to switch programs and go over to the Pro Audio option. All right, auto and run. PCB INF destroyed. I have never seen that message before. We're going to have to look that one up. We need to find out what error 60 is. This is the original DHL shipping label from 1990. Alden Scientific in New York. Anyways. Production management, defective PCB information. Power was turned off during automatic operation. The entire memory is defective. This is saying that the memory that keeps track of how many runs this particular program has been run, not the data for the program. So that doesn't seem like that big a deal, but it does mean we need to find the section where I can go ahead and delete the production data. System 8, 2. Apparently there's only information in there for that. 3. Cumulative. Yeah, see we've got negative 51, which should not be. How do we clear that? Initialize. Okay. Yeah. 1. System. 2. Enter. Auto. Run. Now we're running. Okay. So something happened to the production data. It didn't seem like we were able to clear just the production data for that particular circuit board. We had to clear all the production data. Good enough, gets us back up and running. It's having a lot of problems with that rear row. I gotta go check that feeder. All right, let's see if we get that back row to pick up. This is just gonna add 5 additional components to the circuit board. When we get done with this batch, we're going to have to spend a little bit of time looking at that back row feeder, because it's either the feeder has gotten super sluggish from being rarely used, or else the paper tape that the components are in has swollen and the head is having trouble picking the components out of the tape. It could be either one of those things. All right, we need to fire up the CNC and start machining the enclosures these boards go in. But before I can do that, I need to fix this machine. I actually broke it last time, blew up a drive, and then had to limp along to get through the job, and I just want to fix it before we start. When I originally did the conversion, there was one little thing that I didn't finish up to the best of my ability, and that came back to bite me in the butt. I have ordered some parts, they've come in, and we'll slide the machine out, we'll get back around to the electrical cabinet there, and I'll show you exactly what I've burned up, and hopefully we can fix it. It's on wheels, but it's heavy. All right, I think we're gonna go handheld with this because there's not a lot of room back here. That's the evidence of our unfortunate accident. So, this is the drive that runs our spindle motor. We had an external braking resistor. It just helps absorb the power when the motor is stopping and allows it to stop faster. This should have been mounted up in here or someplace. I never did that, and it plugs into, as you can see right here. Well, what I did was I had just set it on top of the machine. I kind of left it up there and forgot about it. And then one day I came along and noticed that the machine was not as close to the wall as it possibly could be. So I pushed it back and didn't give it any thought. Well, the next time I turned the machine on, that created a short, pushed these wires right into there. It blew up the transistor that turns on the braking resistor. So we need to fix that. We're gonna have to pull that drive out of there. All right, we'll get this over the workbench. So here's our drive, and a lot of this case just pops off. Tab down here. And I'm sure this is probably voiding the warranty, but well, I think it's out of warranty. These 3 solder pads right here, they originally held this guy right here. And as you can see, the whole face of it got blown out. So we need to replace that. The majority of the electronics in this device are all handled within this module. So we're fortunate that the thing that blew up was an external device. So this was like this. And I've ordered some new ones. So one of the problems I had with this was when this blew, it took out most of the part number. We had the piece, we were able to piece it back together and infer enough of the part number to get this guy here. Alright, I think the key here is to make sure everything is tightened down before going ahead and soldering these. The soldering iron is pretty well cooked. This is actually tip tinner. Alright, that can go back in now. Let's get it reinstalled. Hopefully we fixed it. Well, that was far easier than I expected. That's in. That's in. So if you are interested, I've got a whole video explaining exactly how this electrical panel works. We're probably going to put that right up there like that. But before we mount it, we're going to power this thing up. I'm going to go hit the breaker, and you're going to get to hear the explosion if it doesn't work. I did not hear an explosion, so that's a good sign. I am going to power it back down, and we are going to get this thing permanently mounted. M3 S5000 M5 spindle fault. So that little repair did not fix our problem on the CNC machine, so I'm going to have to continue to limp along. And when I get a chance, I'll dig into it again and see if maybe there's something in the circuit prior to that transistor that's still holding us up. And I just wanted to take a moment to say that I know there's probably a lot of you that want to see me get back to the carnival ride restoration, and truthfully, nobody more than me. But these projects, building these controllers, actually helps fund the restoration of the carnival rides. That's not a cheap project, and I was sick for most of November and December, so I'm kind of a little bit behind here trying to catch up, but I'm feeling good again and hoping to put everything on the fast track to keep this thing moving. All right, so last night while working on the CNC machine, I started to smell something hot, like an electrical type burning. And of course, I'm, working in the electrical cabinet, so I'm a little bit worried about that. But it turned out that it was actually our little electric heater up there. So right now the shop is 37 degrees and we have no heat. We've worked on this before, and it's the fan stops. When the fan stops turning, it heats up and heats up until it trips the over temperature. I think I've pulled the fan apart twice now and oiled it, and I'm just done doing that. So we're going to get up there and install a new heater. I am really hopeful that the bracket for the new one is identical to the old one, and I can just swap it out. That would be ideal. All right. If it's not the same, it's very similar. It's weird that it's in here upside down. Yeah, I get the feeling this is used. Somebody had a bag of machine screws in there. And knockout's already knocked out. And I'm not sure why somebody decided to drill a hole right there. And there is no screw for the ground screw. We'll install it and see if it works. I thought maybe this was just how they hung it for powder coating, but after seeing everything else, this thing was used. Unfortunately, I don't have time to return this because the workshop is just continuing to get colder. And the knockout is too big for this. I'm just going to get this tied in, see if it even works. Get the garage heated up if it does work, and then we can go back and fix it. Power on. Well, all we can do is wait and see. It is noisy. It's currently 38 degrees. So this has been running for about an hour, and we're up to 55 degrees now. So it is raising the temperature in here. I don't think long term this is going to work, especially with making videos in here. This fan, it sounds like a jet engine, and the way this is wired, that fan runs continuously. The main reason I bought this particular one was because it's cold outside and I needed something fast, and this was the only one available locally. Long term, I don't think this is going to be the answer. So I think I'm going to order something, take a few days, but we'll just have to keep this up. All right, take 2 on heater replacement. Hopefully this one will work a little nicer and actually be new. Okay. L1 is right here. Turn the breaker on. Well, right away I can tell you this fan is much quieter. Set it for 70 and see what happens. Near as I can tell, that temperature is within about 2 or 3 degrees of what I believe the actual temperature in here is. So I'm just going to let that go and see how it stabilizes for a while. And then I'll get the cover back on the bottom of it. I wanted to answer a bunch of questions in this video that were down in the comments section of the last video. The same questions kept popping up over and over again. So as I was doing this production run here, I was going to be answering some of those questions at the appropriate time. Unfortunately, all these repairs in the shop took way longer than I expected. Most of these repairs I wasn't expecting to make at all. So I'm going to call the video here, and we're going to start a second video where I actually complete this production run and answer some of those questions. So if you don't want to miss that, click that link to the left and come along for the ride.